Okay. So now we are going to discuss interfaces. I've been telling you in Java, there are major components like classes and interfaces. We have seen what class is. Class is a template for an object and it has members representing state of the object, members representing behavior of the object. And we have also seen examples of classes objects. Now, interfaces. So interfaces are the other components in Java introduced and they are similar to classes. Yet there are differences between classes and interfaces and we will discuss all those in this session. So let me show you interfaces. I'll write here then. I'm just finding out. Yeah, here got interfaces. So these interfaces are similar to classes. They also have variables and methods. So, but there are specific properties for these variables and methods. Variables in interfaces are by default public, static and final. So before discussing this final, I need to introduce this final to you and also we need to talk about static. So let us discuss final, static, then we'll come back to interfaces because you need to understand what public, static, final is. So let's talk about final first. So let me find out some notes on final. Yes, here you can see. And before getting into final, I did we discuss naming conventions in Java? Coding conventions or naming convention?
Yeah, the naming convention.
Okay, that is every class begins with uppercase and every second, third word in the class begins with uppercase, right?
Mm-hmm.
Yeah. Okay, fine. Then final keyword. So we have seen this keyword, super keyword, and now we will see what final keyword is. This is one of the important interview questions, final keyword. So final keyword can be used with the variables, methods, classes. So what happens when we use final keyword with the variables? So those variables become constants. So you can see here, I have declared a variable age of data type integer and I marked it as final. Then I am giving a value 18. In that case, this variable age becomes constant. So constant value cannot be changed in the program execution. So to mark some variable as constant, then you can qualify that variable with the keyword final. And I already told you constants are written in uppercase. So age, that is why I have written age in uppercase. Similarly, you can write another example, final int maximum strength equals to 50 in a class. So here you can see I marked it as final. So final, then data type, then variable equals to value. So final variables are constants. Now what happens when you qualify the keyword final with methods? Then methods cannot be overridden. So I go back to overridden. So overridden is a concept where you are redefining a method in subclass. So there is the method in parent class and you are going to redefine a new behavior for the parent method in subclass. So over there in parent class, if you want some methods should not be overridden by the programmers. In that case, you can mark that method as final. So final and of course method signature. Why data type void each. So each is the method name. So here once you mark a method as final, then the subclasses when they try to override, then JVM will throw an error that this method is marked as final in the parent class and we cannot override. So final methods cannot be overridden. Then what happens if final keyword is used with classes? So you can see here while declaring a class, class A, open brace, close brace, class B, extending A. So you can see here class A I have defined here and I marked it as final. Of course in class A here goes those variables, methods goes here. So when you mark class as final, then such classes cannot be inherited. It means while designing your program module, you are creating some classes and those classes uh, should not be inherited by someone. It means someone from some other package or same package writing a class B, extending class A, which class A is marked as final. In that case, this statement of extension will, will not work. JVM will throw an error if you try inheriting class A because class A is marked as final. There are such classes in Java API. For example, string class in Java is in Java API is marked as final by default. So you need to remember some class names which are marked as final in the Java API. So I repeat, Java API is nothing but package of all the classes, interfaces, methods, everything present in the Java. And let me show you the Java API for you so that you can refer to it at any point of time. And let me open Java API for you. I have already downloaded it. If you wish, you can download that. So you can download API for Java 8 version also. I downloaded somewhere long ago Java 7 API. So it's around 120 MB index here. Java platform standard edition 7 documentation and here goes Java SE API. This. So here you can see it is showing all the packages. If you want all the classes also it shows, you can click here. So I told you right, Java language has n number of classes and interfaces. You can browse through all those classes and interfaces that are present in the Java through this API. So it is accessible online also, online, offline, both. So if you want to access offline, then you need to download this and store it on your machine. If you want to access online, you can directly Google out. So here goes packages. So it is showing all the packages here. So Java Applet, Java AWT, and Java IO, which we'll be seeing in our upcoming sessions, Java.lang package, and Java.mathematics library, then Java.net networking, Java.nio, new IO, that is input output to read data, write data, yeah, to some files. Similarly, RMI, remote method invocation, security related, Java SQL, which deals with the JDBC, that is Java program, interacting with database, Java.text to format the text, Java.util, which has all collections. So this is very important package, Java.util. We will see this package, we'll browse through that. Java.util, which talks about collection framework. Similarly, Java.swing, which talks about you can write UI based components like button, label, radio button, check buttons. So all these things you can create using Java.swing, Java X swing. So here all these are packages. If you want classes alone, then you can refer to classes here, all these classes. So what I'll do is I'll take you to one package and show you the classes. So Java.lang package. There is some speciality about this package, Java.lang package. Java.lang package. Let me open Java.lang package. So from this Java.lang package, you can see interfaces and classes that are present in that particular package. So here, interfaces like runnable. So runnable is an interface. I will introduce this interface when we are talking about threads. Then let's see the classes present in it. Classes. So there are classes like, so what I'll take you to system class, which we have been using system. System.out.println we have been using. So this system is actually a class present in Java.lang package. System. So I have clicked on system class, and here goes all the elements that are present in the class system. So you can see system. I have been using system.out.println. So system, here you can see out. System class also has in element which takes input. Error to show errors. So here you can see out is nothing but a print stream object. We will see these stream objects when we are discussing IO. For now, you can just keep in mind that out is nothing but the output device on our computer, that is monitor. So here out, and here goes the various methods that are present in Java.lang package. So from these methods, I will highlight few methods. So here exit method to exit the program, and GC, garbage collection. We will talk about what garbage collection in Java is in our upcoming session. GC, so run the garbage collector, then get the properties of your system, get properties. Then if you want a particular property, you can pass the property and get the value of that. Then so if you want to study about these methods, you can click on any method. So GC. So here goes. So all the definition and syntax, everything is explained here. So similarly, if you see mathematic package java dot math class, let me, here goes math. Java dot lang math class. Math. So math class. So which has all mathematical related functions, methods. So E, capital E value in mathematics, pi value, 3.14 and so on, pi value, and you can see they are constant. That is why they are represented in uppercase. And here goes absolute value of a particular value. Then, so it is, you can see here there are overloaded methods. Absolute function, that is method which takes a double value or a float, integer, long value. Then you can see sine theta, cos theta, trigonometric related mathematic function, seal, cos theta, then exponent, logarithmic to base 2 and base 10, maximum of two numbers, that is double numbers or float numbers, integer numbers maximum, similarly minimum of two numbers, then random number, to get the random number, power of a number, rounding a number to integer, square root of a number, tan theta of the number, converting to Celsius to degrees, to radians, yes, these are the various methods that are present in math class. So math class. Similarly, if you see here classes in java.lang package, I'm going to highlight few more classes. So here goes object class. Look here, object class. I would like to introduce something about the object class. So let me open this object class. Capital O it is. To remember here, this is also one of the important interview questions. So object class is the root of the class hierarchy. The entire class hierarchy present in the Java API, object class stands on top. Every class has object as superclass. It means whatever the classes we are writing in our Java program, all are inherited from java.lang.object class. It means, let me show you my Eclipse. So we have been writing test drive polymorphism 1 class, dog 3 class, mammal 3, animal 3. So whatever the class you are going to write, it is by default extending object. Look there, when I introduced those two words in the program, it is not showing any errors. I have already saved the program. It means that our classes, whatever we are creating, are by default inheriting this java.lang.object class. So that is why they said over there, object is the class that is present on top of the Java API, which is the root class for all the classes that are present in the Java API. Similarly, if you have this also extends object. So I have saved the program, still there are no errors. It means JVM is accepting that. Yes, the class is inheriting from object. So all the classes present in the Java API as well as user-defined classes, programmer-defined classes by default are inheriting from java.lang.object. So this is the supermost class in the Java API. Let us see what this class object has inside it. It has, yes, here goes the methods. I'll highlight few methods. Here, hash code method. So hash code is an hexadecimal code that is generated for every object. So this hash code we can consider as ID of the object. Every object will be having a unique hash code, and this hash code is generated by the JVM and tagged with the objects which we are creating for our classes. Similarly, equals method. Equals. If you want to compare two objects, then you can use this equals method. Of course, we will see this equals method when we are talking about strings. We compare two strings. Then finalize method. So finalize method I will introduce to you when we talk about garbage collector. So finalize method is nothing but a method which allows the programmer to write some code to what do we call, clean the resources. So Java has garbage collection mechanism which by default is executed by the JVM, and it will clear the memory occupied by the objects. So before clearing the memory by JVM, it allows the programmer a chance to do something about the object, because JVM is going to kill that object to gain the memory. So that in that chance, if you want to do something with the object, then you are going to override this finalize method. So we will discuss that soon. Finalize, then notify all. These two methods are related to threads. So when something is happening with the threads, then they can give a notification to operating system. So notify all, wait. These three methods, so notify all and wait methods belongs to multi-threading concepts. Two-string method. So two-string method is something used to represent our Java objects. I will show you by example how to use this two-string method. It is nothing but textual representation of a Java object. That is, you can give a meaningful description for your objects. I'll show you by example this two-string. So these are the various methods that are present in java.lang.object class. So this is Java API, and if you wish, you can browse through this Java API to understand the definitions of methods, constructors present in Java components. And java.lang package, actually I highlighted here java.lang package. So there is something specialty about this java.lang package. The specialty is, the thing is, when we are writing Java programs, we have never used any import statement actually. Import. So if you observe over there, I have been using Java API class system.out.println. System is actually a class present in java.lang package. You can see java.lang package. So whenever you are using some classes that are present in packages, then you need to import those actually. Java dot lang dot Java dot lang dot system. So here you can see I have imported system class. It means that this system class can be used in your Java program then. Even though this java.lang.system class was not imported in our programs, JVM did not complain about this. The reason is your Java programs, whenever you are writing, JVM will supply the entire java.lang package to your programs by default. That is why till now we are not importing any of the components that we are using and that are present in java.lang package. We are not importing them because JVM by default supplies this java.lang package to your programs. So here you can write, you can import every class present in the package like this, or you can just mention star, java.lang.star. When you mention java.lang.star, then it means that all the components present in java.lang package are available to my Java program. So the recommended approach is don't use this java.lang.star, any package.star. Instead, you better import each and every component whatever you are using in your Java program. So recommended approach is to import the classes one by one in your program. Do not use java.lang.star. The reason is, look, in a package there may be hundreds of classes components. So assume java.lang package itself is having 20 classes. So in your Java program, you would be hardly using 3 to 4 classes present in the package. In that case, mentioning java.lang.star will not be wise because java.lang.star, when JVM reads this statement, then it makes all the classes that are available in that package will be available to your program as well. So while you are using only 2-3 classes and telling JVM to import all the classes for you doesn't make sense. Instead, you use whatever the classes you want by importing them separately in this import section. So this is also one of the important interview questions. They may ask you, why don't you use star? Why are you using all the classes one by one to import? That is for effective memory utilization. And let me compare this java.lang. Import section. Import section, if you go back to your C programming, in C programming also we have this import section. I already simulated, I have shown the comparison with the C programming import section and Java programming import section. In C programming we generally write hash include stdio.h or hash include string.h. So string.h, math.h or console.io.h. So here in your C programming, when you import this library stdio.h, string.h, so when you are importing this string.h, it means all the functions present in that string library are available to your C program. So what it means is you are making sure that the compiler is going to get all the functions that are present in this library to your program. So here another internal similarity I am discussing with you is when you are writing hash include stdio.h, hash include string.h in C programming, what internally happens is, look, if you take string.h, there are methods like concatenation, trim, so trimming a string, like this, there are plenty of methods. So every method, I mean to say every function, because in C programming we call them as function. Every function has code with it. So here, when you are using hash include stdio.h or string.io.string.h, the function and function code is going to copy into your program. It means if you write 100 lines of code, then from this stdio.h or string h library, whatever the libraries you are including, the code from the library is also getting copy pasted in your C program when your C compiler is going to compile and execute. It means C compiler will see 100 lines of your code plus maybe thousands of lines of code from these libraries during compilation, which means your program size would be grown during compilation, which means compiler will take time to analyze your program. So what happens when you are using import statement in your Java language? Where the import statement is similar to hash include. This section in C programming is known as preprocessor directives, we call it as preprocessor directives, we call them as. There is another alternate name, that is linkage section, we call it as linkage section. You are linking the libraries of stdio.h to your program. So what happens with import statement in Java? With Java, so what happens is when you use import and so on so classes, those classes code is getting compiled and the output of that component, the output of the method is going to be available to your program. No Java code is going to copy from that particular import statements to your program. It is the result of that components which you are importing are available. So the program code does not grow during compilation. So the output, the result from that components which you are importing are available to your program. Hence Java program execution would be faster. So this is one of the important interview questions. So what's the difference between import section in Java and preprocessor directives or linkage section in C programming? Yes. So before getting into other things, I have to give you an example of toString method. So toString method. So let me give you an example considering our previous example which we have been using, that is rectangle class. So rectangle, yes, rectangle. So here you can see I am referring to the previous example, class rectangle has variables length and breadth, setter getters, set breadth, set length, get breadth, calculate area, then test drive rectangle with the main method, creating the object, setting the length breadth, then calculating area. So what I'll do is, here I have created a rectangle object. Did you try any time printing this rectangle object onto the console? So that's what I am doing now. Print the rect object onto console. So system.out.println. So what I am doing is print rectangle object, and I am going to print here directly plus rect object. I am saving this and I am executing this program. Observe here what JVM will print for this. I execute this and here goes what it has printed for java.lang.object. Yes. So look here, when I tried printing the rectangle object directly on the console, JVM is printing something like a com.java.core.demos rectangle. So it is printing the object's class name along with the package. So rectangle is the class name. Along with the package where it is located, com.java core demos is the package. Also, it is printing some alphabetical and numerical. So CF2, C80 and with an @ symbol, separated by @ symbol actually. So here, when you print rectangle object, I mean any object onto the console directly, it is going to print the entire package name and class name and some alphanumerical code separated with @ symbol. So this is what it is going to print. So if you print any object onto the console, it comes like this. But when you are working, reading this, the user, so when you display a rectangle object like this to the user gets confused what these dot or dots and these, what this, he doesn't understand. So we need a meaningful representation for rectangle object that can be done using toString method. So before getting it, let me show you the hash code. So print the hash code of rectangle object. System.out.println, I say the hash code of rectangle object. That is nothing but rect object dot hash code. You can see hash code return type is integer. So I say hash code. I save this. Now I execute this. So previously it displayed this and this. You can see now rectangle object when hash code is printed. I told you right, hash code is nothing but an identification, a numeric, a number that is tagged with this rectangle object. So in JVM memory, this rectangle object can be referred to with this hash code ID. And I execute this again. Observe carefully. Here CF2C80 is the alphanumerical code and this is some ID here. I re-execute this. So CF2C80 and 13577344 you can see remains the same when after second time execution also. Third time execution, fourth time, fifth time, sixth time, 10 times, multiple times. So you can see here just now. Yes. So it is generating some ID. Maybe it is internally changing its ID. I mean the memory area it has changed. So here what I want to say is this hash code is unique to object. And here, yes. So this alphanumerical code is nothing but hexadecimal code we say. So here JVM is going to print the hexadecimal code for the object and this hash code is completely a numeric, completely an integer value. So internally this hexadecimal code is converted to integer and that integer is being displayed here on the console by this hash code. So there are certain hashing algorithms where this hexadecimal code is converted and it is displaying the integer value over there. So that's about hash code and a rectangle object toString method. I will override and display a textual representation of my rectangle. So what I'll do is I am getting into my rectangle class. Inside my rectangle class, here override toString method. So toString method. So why? To represent a meaningful description of rectangle object. So what I am doing is now override. So override, so you can see to string, so you can give a control space. So toString method actually override method present in object class. I already told you any Java class which you are creating by default inherits from object class. So this override method we are overriding from this object class. Let me do so toString method. And here what I am going to do is return. I am just changing. So what I am doing is whenever my rectangle object is printed, it has to display the dimensions of the rectangle. So I say the length. So what I'll say is rectangle length, and breadth. So I can use plus length plus breadth equals. So observe that I am making use of those variables. So I am displaying length and breadth. So let me execute this and I'll show you. So here whenever you are displaying rectangle object onto the console, this time it is not giving any package name, symbol and those alphanumerical hexadecimal code. Instead it is displaying the dimensions of a rectangle object. So here as of now it is 0 0 because you are invoking here. Suppose if you invoke this after set length set breadth. Now of course it will show length 12 and 10 respectively. So what I have done is in my rectangle class I have overridden toString method so that whenever you are trying to print the rectangle object onto the console, then user can understand, okay, this is a rectangle object with so and so dimensions. So here, while displaying this, you can, so let me, rect object, either you can do rect object dot toString or even directly also you can. So after adding dot toString, I execute again, so still remains the same. That is, by default it is calling the toString method when you are trying to print rectangle object onto the console. So that is why we use the toString method in Java classes. This toString method is actually present in java.lang.object. So toString method is used to give a textual representation of your object, so that when displayed, it displays, my rectangle object, I displayed the dimensions. So for the other objects which you are trying to display, you can give a meaningful representation, meaningful description for your objects by overriding toString method. And here at the rate override symbol, this is an annotation, and we will see annotations in our upcoming sessions. Maybe it takes another 1 or 2 weeks to get into these annotations. So that's about java.lang. Object class methods, and I just came from final keyword to all these. Then, so I need to discuss static. So to discuss static, it may take time. It's all around 7:30, and I would like to wind up my session, and we shall see tomorrow, and I'll talk about the static. Then we will get into the interfaces tomorrow. All right. I am closing my session for the day, and I will upload this and the program code to you. Okay.
Okay.
Right.
Fine. See you tomorrow. Welcome.
Okay. Bye.
Okay. Bye bye.